Okay, so you see the solution is converged here. Now we'll check the results. So what I said is the domain we are using for this case, this is very small, and definitely it will not be turbulent because the cross-sectional area, the heat transfer surface area, and the length of the tube, this is very small. However, I used the turbulence model and the velocity is 0.05. I said actually I want to play with different parameters to give you some understanding like how to deal with this heat transfer problem, because in many problems you can see that you're working with these projects and you got no heat transfer. So let's see, go to the neutron calculation, so go to the results and then graphics, select the contour setup, select all the domain from here and select the temperatures and click on display. So you see what we got. Actually nothing happening. So this is the hot plate domain, this is the cold plate domain, and this is the wall. We can see actually no heat is transferring here. Maybe you can see little gradient here, but actually you see no heat transfer is happening here. So this is because the velocity we're using in the turbulence model. So what I will do is I will tell you, go to your boundary conditions, maybe select the velocity L, smaller velocity, more smaller velocity for the hot and the cold fluid. So yeah, you click on OK, go to the model, and instead of the turbulence model select the lambda model here, and let's see how it goes. So what we'll do, we'll initialize it again, click on OK, and we'll run the simulation again. So now we need to wait for the converged solutions. So would you know it will take a little bit time to get the converged solutions. So once the solution is converged, then we'll check the results again, how the heat transfer is happening, whether it is. So for the previous case we found no heat transfer actually from the cold fluid, hot fluid to cold fluid. So you can see the contours actually here, the temperature contours. The solution it converged, and if we go to the contour, if I select everything and if I click on the compute domain, so yeah, so if I selected whole domain and if I say okay, click on okay, show the temperature, so then you can see now some heat transfer is happening. So it is our hot fluid domain, it is our cold fluid domain. So actually when you see this one, you see that heat is transferring from the hot fluid to the cold fluid. So the thing is, when we use the turbulence model and then we found no heat transfer is happening from this hot fluid to cold fluid, but now when we change the model from the turbulence model to the laminar model, then we found okay, now heat transfer is happening. So you need to play with these options, and I also change the flow rate. I make it 0.05. So let's have a look again. Let's say we are going to use this laminar viscous model, but for the inlet and outlet conditions we're going to use maybe the velocity like maybe the 0.5 meter per second, and for the cold not cold, so this is the cold inlet, we need the hot inlet, so this is the hot inlet, so let's say this is also 0.5, so click on OK. Now initialize this problem again, so initialize it and run the calculation. So now what you're doing, we only change the light hot fluid and the cold protein light velocity. Yeah, we put some the higher velocity, but we're using the laminar flow. And now we will see whether this solution converges or not. So it's pretty much done. Yeah. So you can see the solution is completed. So we'll go to maybe this contour. So when we say we're still using the laminar model, and we increase the number of the velocity, the light velocity, and for the cold and the wet fluid. So what I found, we can see some heat transfer is happening here. So this is the wet fluid in light and the cold fluid in light. So you see, we found some heat transfer is happening here, and but not that much. So you see, actually, it will depends like what you're doing, what is your project. You need to play with this. You need to find out which model will give you better solutions. So I will do one more thing here. So this is, I think, the best thing. In the state of the wire system coupling, if I say the heat flask, okay, and I'll put the cell conductions. So one layer, I'll click on edit. I'll put a little thickness for the domain, like for this, for this part, a little domain, and the material is this, and there is no heat generation is happening. So I'll put this thickness 0.01. So I believe it will also work. So if you click on OK, so instead of wire system coupling, now we are using the shell conduction. So click this thing. I will initialize it now. Okay, I'll click on that, then run calculations and see how it goes. So now that you see the simulation is running, so definitely we need to wait until this solution is converged. So once the solution is converged, then we will check the results again. So you see the calculation completed, and now just have a look the contours. So if you see the contours, you can see I didn't change the velocity, but I used the method like the shell conduction, so it improves the heat transfer a little bit more. Previously it was later heat transfer there, and now you see it's if you compare with the previous setup, you see we can see some heat transfer here as well. So if I do just one more case, like if I decrease you see this velocity like this, like what we use for other case, then let's have a look. So you can play with different options to enhance your performance. So yeah, I'll initialize it again, and I'll click on run calculation. So calculate it now and see how it goes. Yeah, so you see the solution is converged, so now it's calculate. Close that one, and if you click on the contours, if you save and display, then you can see how the heat transfer. Most of the heat are transferred, you see here. Seems they're almost same the temperature from this zone and this zone, but we can see still some low temperature, the minimum temperature 3 here. So there's some technique actually you can follow when you will do your projects or your future projects. So there are a lot of things actually, but if I discuss everything it may confuse you because you have just started with this project. So I'm not going to discuss some advanced techniques like how to deal with this heat transfer, but I think I tried to give you some basics, some preliminary understanding actually how to deal with the basic problems. So my definitely I will upload one more videos for some advanced post processing, how to deal with the heat transfer results once you have done with the simulation, how you will do the post processing for this results. So that's the end of this video.